Hello everybody, in this video I'm going to show you how to create a multitasking applications using ESP32 toolchain and ESP32 chips. So let's get started. As you can see, I'm using Visual Studio Code and the Platform IO as a development environment and a compiler. But you can use an Arduino IDE, regular Arduino IDE, and it will compile, but you have to make some configurations before starting. But they are the same. They are using the same toolchain to compile it. Let's open a new project. Open the Platform.io homepage and create a new project. Let's give a new project a name. Multitasking. And let's choose an ESP32 board. I'm using Espressif regular development board. And I'm using Espressif official development framework for my purpose, but you can use Arduino also. That's great. If you are doing this at the first time, it will take a while because it will download the required packages, required framework and toolchain from the internet. It will take about 10 to 15 minutes. But if you did this before, like me, it will create eventually. So before starting our project, we have to configure our serial monitor speed for 150 200 because this is a regular baud rate for ESP32 output, but the platform IO terminal is configured as 9600 baud rate, so you only see garbage if you don't configure before starting. So after starting, we can close this in file, and also we can see our source code is a main C, but we are going to use C++, so we have to change the name of our source file, so it is now as a C++ source file. So, but we have to make some configuration to start it. It's a magical keyword to compile it successfully. You can do this, and I'm not going to explain why I'm doing this because there are many explanations you can check on the internet. So we created our first project. Let's start multitasking. We need some libraries, some header files like Fritos, and also create some tasks we need. Now we have our header files included, and let's get started. So the typical task function is declared like this. Let's say print function, print task. Let's keep it simple. And the only parameter it can take is a pointer, void type pointer. And let's define our this is the only parameter we will use. So we need an endless loop to create a task. So, but we need to fill this task with something like delay. But we are not going to use this regular delay because it will keep this processor busy, and we are using the vtask delay because it gives the resources free the resources for other tasks to perform. Let's let's leave our task for 1 second. So we just created our simple task, and we need to start it. So there are two options. We can create a X task create function and X task create pinned to core. I'm going to use the second one because I want my tasks to run on a different cores. So let's create. First parameter is the name of our the pointer of our task and the name of our task. This is not very important, but it will use some other applications, some other functions, so it is better to use an unique and identical names. So this is our stack depth, but the print tasks requires a little bit more RAM, so we use the 4096 bytes, and our parameter is now null. We are not going to use any parameters right now for now, and then the priority is 1, and then we are not going to use any handle, and the core ID is there. Do you know, as you know, and ESP32 has dual core processor, and there are two processors we can use, 0 and 1, and 0 is the idle processor and the 1 is the other one. You can use both of them and any of them if you wish. I'm going to use the only one, the number 0. So that's it. We just created our first task. Let's run it. To run it, open the platform IO and upload and monitor. It will take some time to compile it. Be patient. Now it's uploading. Now, as you can see, our task is working successfully. So let's create another task and try to share some variables between them. The first thing is we need some variables. Let's say int var variable like 10. So we will pass this variable to our function. So how can we do this? As you can see, the only parameter that our task can accept is a void type pointer. So we are going to create a void type parameter from our variable, integer variable. So we need to cast it as a void type, and also we need to give the address of our variable. So you see, we have our parameters. We already passed it to our function. So how can we use it? We can use it, and where is we need to create we need to get the value from the pointer. So how can we do this? We just use this mark, and also this is an integer because we get the parameter as a void, so we have to convert it to integer. So let's from our parameter. So we can use it now. Let's start again. As you can see, the 10 is our variable. So we passed our variable to the task successfully. So let's create another task and try to share this variable between them. At the name of task 1, as usual, it takes the pointer. Let's define it. So how can, let's create a while loop. This is 500 milliseconds. Just let's prefer it. Let's take our variable and try to change it. So how can we do this? Let's say int myvar. Same. We use the same. Let's try to change it. Let's increment with by 10. Let's start again. And sorry, why we forgot to. This is not a very complicated job, so we can use 512 as a stack size. And let's the variable name priority1, no handler, and we're just going to use the core one. I want both tasks run in different cores. So let's start again. Let me give some less. There is a mistake. Yes. Let's start again. Let's compiling. If you get such errors during the compilation, so the only thing you have to do is to make a clean. It will clean, and let's upload again. Come on. What is it? I'm doing many mistakes. Again. Now our tasks are running simultaneously, but even though they are using the same variable, but they are not changing it. It should be incremented by 10, 10, 12, 30, 40, 50, 60, but it's constant. So the reason is this: we are just passing the pointer to our function, but we obtain the value from that memory block and make a copy to our variable. So we just increment our local variable, not the variable that is stored in the memory block. So to overcome this, we just use the pointer, not the variable names itself. So how can we do this? This is very simple. Let's remove that brackets and pointer mark, and then create a pointer, integer type pointer from our void parameter pointer. So let's create this one, and also this. Now we are using our not the locally created copied variable. We are just using the exact variable that is stored in the memory address that is we passed to the function. So let's start again and see what happens. See, because it is incremented by 20, because the delay period is 500 milliseconds, but the printf uses the delay as 1 second. So it runs twice before the print function print the variable. So you can see the actual variable is incremented by this task and printed by this task. So they are sharing the same variable. So you get the basic idea, but how can we pass multiple variables to our functions? How can we share it? So the idea is the same, but the variable type is different. So we're going to use the struct. Let's start int a as 0 and integer b is 10, integer. Let's use float, not integer. X as 1.2, float y 2.25, and creates an object from this. So we have a variable type, we have a struct object named variable. So this struct contains these variables. So we can pass all of them to our function, task functions, and we can use any of them. So to do this, the idea is very simple. Just use the address of our structure. So let's delete the 10. But the usage, the method that how can we use this struct is a little bit different than the integer. So we just create our variable. So how can we use it? We need to define and type. Let's say again we need let's say the same type, but okay, we have an object, the struct object, locally contained on a function block. So how can we reach the elements inside it? So that's simple. Use this unique, the arrow key gives us how can we reach how can we reach the variables contained by the structure. So this method is simple. How can we change the values? Again, so let's change the value of a. So let's board and monitor again. Let's delete. See the same result. Let's create a couple of tasks and that can change the same variable, the same values inside that structure, and use how they can share the same value. Let's create task 2 and task 3 and define our functions here. Remember, the key point is create this while loop and delay. Otherwise, your processor will crash. Let's gives the delay value is 250 milliseconds, and let's create let's give us 750 milliseconds. So let's change some values. Let's first create a pointer from our past parameters. Let's change. Let's increment by 55, the same variable that is used by the task 1. And also let's change my variable x value. Let's say 2.58. And also get the variable pointers. Let's change some other values. Let's multiply it by 2 and let's multiply it 1.21. So let's see what happens. Give some good looking tab and A, B, X, Y. X and Y is a float, and see, we change the same values, some other values, and print all of them. Let's start. Okay, sorry, we again forget to start our tasks. No handler, and let's start on core 1 again. Task 3. Task 3. Stack depth is 512, and parameter again casting void, and gives the address of variables object, and priority is 1. No handlers, and let's start on core 0. Thank you. And that's it. It should start immediately. I forget to change these values. Let me change them. Okay guys, you can see all of the variables are changing by the tasks and printing our print task. So that's it. Now you can make your own tasks, create new variables, new struct variables, so you can share all the variables between your tasks. So as you can see, there's a Stack Overflow because we just multiplied it, I think. Whereas, yes, we just multiply by 2 and otherwise, and at the end it will overflow. So be careful about it. It's not important. So that's it, guys. Thank you. Thank you for watching my videos. Have a nice day.